This micro-credential deals with electrical problem solving in agriculture and consists of 5 targeted skills. This targeted skill deals with determining wattage. An important characteristic of electricity is wattage, or electrical power. It is based on the voltage and amperage being used in a circuit. Voltage is the pressure from an electrical circuit's power source that pushes charged electrons or current through a conducting loop. It is measured in volts. Amperage is the strength of a current of electricity and is expressed in amperes, often shortened to amps. 1 watt is the equal amount of power being used when the force of 1 volt is generating 1 amp of current. The higher the voltage or amperage, the more wattage or power is being produced. One common use of wattage is to express the size of an incandescent light bulb. 40-watt light bulbs produce less light than 60-watt bulbs. Likewise, 100 or 150-watt bulbs are also brighter when compared to the smaller wattage sizes. Watts are pretty small units. Many applications use so many watts that the kilowatt, or 1,000 watts, is used to express the amount of power being used. Wind turbines and large electrical generators even use megawatts, or 1 million watts, to refer to the amount of energy being produced. Calculating wattage is done by using the wattage formula, which is volts times amps equals watts. This formula can be used to calculate the energy usage for simple resistance loads. If 2 of the characteristics are known, the third one can be calculated. With the watt visual graphic covering up the characteristic that is being requested and its position determines if a person should multiply or divide. When solving for watts, amps and volts are side by side, so multiply amps times volts. If solving for amps, watts is divided by volts. When solving for volts, watts is divided by amps. To practice using this visual, how many watts are produced in a 120 volt circuit which has 3 amps of current flow? To find the answer, multiply 3 amps times 120 volts to get 360 watts. What is the watts for a starter on a diesel engine that is pulling 500 amps in a 12 volt circuit? Multiply 500 amps by 12 volts to get 6,000 watts of electricity for the starter. What are the volts for a device that is using 400 watts with 5 amps of current flow? Watts are divided by amps, so 400 watts is divided by 5 amps to get 80 volts. Technicians use these formulas to help diagnose electrical problems. Engineers also use this knowledge to design and create many electrical devices that make lives so much easier. Knowing how electricity flows, its main characteristics, and how to use formulas to calculate missing values are important for many careers and applications in the agriculture mechanics industry.